The next speaker is Colin Gillespie from the UK, and he will present us the advanced usage of GitHub and how we can connect it to other tools like Twitter. Please welcome him.
Yep. Okay, so thank you very much for coming along. I was trying to think if I've ever given a talk in a nightclub before, and I think this is the first time, so it's an experience. So I'm going to talk a little bit about GitHub and Friends, and similar to the last talk, there were going to be live demos. Unfortunately, Travis broke 6 hours ago, so, well, we'll see how we go. So I don't know, I'm assuming you're all familiar with GitHub, and essentially this talk is about how do you get all those cool little badges on your repo. You know, that's sort of the mark of a good R programmer, I think. So I'm from Jumping Rivers, and we do consultancy, we do training, and we also have a sideline in coasters. So you might have had your little bag and you got your little coaster. So that's what we do. And nothing says 21st century data science than a plastic coaster. So moving swiftly on, you're a tough audience. All the material is there. So the top link are the HTML slides that I'm going through. And the second link is a GitHub organization. So not just a repo, but an actual organization that contains all the bits and pieces. Okay. The organization contains a dummy R package used for this talk. It contains the markdown documents with slides, a drat repo, which I'll explain about in a second. And this talk uses Git and GitHub, but you could use other bits of software. Just don't ask me a question on it at the end, right? So you can sort of switch into GitLab and other bits and pieces, and it should just work, but the configuration's a little bit different. And there's lots of credits and lots of links to all the packages that I mentioned and I didn't develop at the end, okay? So we all use packages, don't we? Yes, I'm sure we all do. So packages are great, right? They give you version numbers, so that's quite good. They enforce documentation, right? So we're made to write documentation. Can't force us to write good documentation, but it tries hard. So we're made to write documentation. And the best thing is automatic code checking, right? And so a bunch of automatic checks. So the minute you put your I'll use the word, the minute I put my dodgy little R script into a package, it starts checking things like, have I missed off brackets? Does it compile? Does it work? Am I missing off libraries? It does all these cool things for free, right? So I don't just use packages for, distributing bits of software. If I'm writing an academic paper and it's just got one or two examples, I would put that in a package. And it's not a package in terms of, it's got lots of interesting, functions. It's just a way of making sure everything works in different platforms. So packages are great, right? So if you don't use packages, you should use a package. And we all use version control, I'm sure, as well. So the first speaker mentioned something called SVN, and I grew up in CVS and SVN. So throughout this talk, I'm going to use the word commit when I really mean push, because we're talking about Git. So in this talk, sort of commit/push are the same thing. But we all use version control, and we get to avoid this wonderful directory structure. Thesis 1a.r, thesis 1a.r final, thesis 1a.r final, I hate my degree. I'm sure if you've been at university, you've probably got multiple of these, and perhaps a few choice comments somewhere in that R script as well. Allegedly, I use that word allegedly, makes it easier to merge documents. I think it just makes it less painful, but it's definitely good. And I think most people agree that, version control is a good thing, right? We should use that. We should use packages. I don't think that's controversial. And then we've got, I suppose, a data science workflow. So this was the most painful cartoon I've ever had to create. So I'm not an artist, and my neighbour's an artist. So I had to explain to Bethan all about data science and algorithms and machine learning, and she knew nothing about that. So it was a really hard conversation. And then she said, so what do you want me to draw? And it's like, I don't know, you're the artist. Can you not just draw something, and make it look nice? And so then she had the revenge of saying, well, that's just not very good. So essentially here in this little cartoon, the take-home point is, this is all automated, Right? We try to automate as much of this stuff as possible. Now, it's not possible to do it entirely automated. Right? There will be a little human jumping up and down somewhere in between. But where possible, we want to make these things automated. Right? Because it gets, it's fun the first time, but the novelty sort of wears off very, very quickly. So we don't want to be doing boring stuff. We want to be automating it. So we want to automate whenever possible. Right? That's essentially the key takeaway message. We want to automate whenever possible. And I don't really trust myself to write good code 100% of the time. I don't know what that number actually is, but it's definitely not 100, and I definitely don't trust any of my collaborators. In fact, let's face it, we don't trust anyone to write good code 100% of the time. We all make mistakes. Okay? And so the solution is, well, when we push a commit to GitHub, we want as much automation to check that and to do everything we want as possible. Right? So we want to sort of leverage all of GitHub and Travis and everything else we're going to talk about to make sure we don't do something a bit silly. Right? And if you look through my Git commits in a few projects, you see I do silly things quite often, and Travis picks it up. So, what's Travis? So that little thing at the top says build error, right? So that's a live badge, and it turns out that Travis broke, or the Travis R version broke about 7 hours ago, which was great timing, so thank you very much for that. And Travis is a continual integration system. So essentially what that means is we push something to Git, or GitLab, or GitHub, or whatever you want, and then Travis goes off into the background and does a bunch of checks. Right? So it does something. And it's not an R thing, it's just a general computing thing. So if you did some Python or C or whatever, it does a bunch of checks. Right? So this morning we were actually using it for a LaTeX document. Right? So it wasn't anything to do with R, but we are collaborating in LaTeX, and we're just making sure, does it build? Can we trust people to do LaTeX correctly? So what's going to happen is we're going to push to Travis, and then some stuff is going to happen. Okay? And it just checks we haven't done anything too stupid. So how do we do this bit of magic? Well, what we need to do, it's quite easy, is we add this file travis.yaml to your repo. Okay? And then at the top we specify, so this is just a plain text file. Right? There's been a lot of work going into this, making all this work by a lot of people, and there's a link at the end. So, again, I didn't do this, but there's a lot of work by lots of different people. So this is a little simple text file. We specify the language R. Right? And then this second line cache, essentially the first time we run this, it'll be a little bit slow, but the next time it's cached all the packages we used, and it'll be a lot quicker. Okay? And then we specify the version of R that we're going to use. And, well, we'll go all out, and we'll specify R past, present, and future. Right? So, it's a bit of a pain. It's not hard installing R on your laptop, but installing all 3 versions and making sure everything's up to date is painful. So what's going to happen here is we're going to do a push, and then Travis is going to check in all 3 different versions. Right? So that's quite nice. And then we've got a little line saying, well, if something changes, so if something starts to break, I'm going to get an email to say you've been a bit stupid, right? Go away and fix it. So in general, what this is going to happen is it's going to run in the background. We're not going to hear any notifications unless something breaks in Travis. And what this will do by default is it will try to build your repository as an R package. Right? So if your repo is an R package, putting this into your repository will set R off to build all this stuff. And we need to authorize it at this URL, travis.ci. So you can go from a repository with an R package to setting this up in about 60 seconds, right? Maybe 90 depending on the Wi-Fi, right? So if you're a relatively simple package, you stick this in, you log on to Travis, it's all hooked up to GitHub, and that's it, and it will just generally work. So that's quite nice. So we can check our package. What else can we do? Well, we can check the test coverage. Right, so we've got a unit test suite. So my package is particularly well tested here. We've got a whole 0%. Zero's bad, in case you're wondering. And we can, so a test suite would be where you've got a set of unit tests that specify the input, specify the output, what should break, what shouldn't break, so on. In case you're wondering what that looks like, it looks something like this. So that's my package. It contains a whole function called the function add. So it's generally not a good function. It does work. And I've not tested this line. So I've got a little red bar saying you've got some code in your package and you don't have a unit test to look after this. So you should go away and write a unit test. Right. So that's quite good. Again, you set it up and it just sort of chugs along doing nothing. So that's quite nice. And in order to write that, well, you add another couple of lines to your Travis file. Okay? So here we're specifying an extra line saying R packages, and our package that we're going to use is this COVR. Right? We don't really want to put that as a dependency in our R package, because then that means that all users have to install that, so we probably don't want that. And then we've got a little line at the end saying after success. So what that's saying is, well, you push your change to Git. If everything works, if you pass, you get a big tick, and we'll run that little line of code. Okay? And that'll just check your test suite. If you've got 3 different versions of R running, you're probably not wanting to do that for all 3 versions, so you can have a little if statement to say only run it for, say, R current. Right, so it's quite easy. We can check our coding standards. Okay, so there's a package called lint-r, and again, we'll check the coding standards after success. This also works in branches or pull requests as well. So you're not just working on your master, but if someone's doing a pull request, all this stuff can kick in. So that's quite nice. And what that looks like, well, what it would look like for me is it would tell me off for using the equal sign. Okay, so as Martin mentioned yesterday, we shouldn't be using the equals, and he also told me off in my talk on Monday. And so we shouldn't be using the equal sign, and you'll get a little warning saying, perhaps you should change your thinking in this. This is the thing that we use most at Jumping Rivers, okay? And R is really good for packages, right? The packages are amazing. So I've got a confession. So 2 weeks ago I installed Python, and it was a nightmare, right? I just had paths everywhere. I think I had TensorFlow in 3 different places in my laptop, none of which worked. It was just awful. R's packages are amazing. If someone asks you how do you install Shiny, you do install.packages Shiny. You don't have if you're in this version, or if you're in a Mac, or if you're in Linux, or if you're in Windows. It's just, that's what you do. We all know that. So a repository is just a bunch of packages, but in a particular way. Right? So it's just not a random directory filled with some stuff. There's a structure to it, and you have a sort of a folder for binary files for Windows, one for Mac, one for Windows. Okay? And it can be hosted on a web server, so CRAN. It can be hosted on a USB stick. So when we're doing training courses, we typically have a USB stick filled with packages as a backup. Or it can be an internal directory file system. And if a package is in a repository, we can use the standard commands, right? And that's good. So the one downside, or the big downside with install_GitHub, is you install someone's developmental version of their package, and they update it tomorrow, and you don't know, right? So every time you install _GitHub, how do you check if something's been updated? It's hard. Whereas doing it this way, it all just works. So drat is a really nice little package, right? And essentially drat takes care of what that directory structure is, right? So we don't need to care about the directory structure of a repository. Drat just sort of generates it all and takes care of all the folders. And so if you run that command, insert package, it will figure out it's a package of Windows or a Mac package or a Linux, and then create the directory structure, update the necessary files, and do everything for you. Okay? So drat is just a way of creating a repository. Right? And what GitHub makes easy is it makes it easy to make web pages. So if you've got a repo, if you create a branch called gh-pages, you've automatically got your own web page. Right? So GitHub makes it easy for web pages. Drat makes it easy for doing inserting of packages. So the big picture is, if the package builds and it's successful, we run insert packages. We then push that package to Travis, and we can specify the URL install.packages work. Right? So push a package to GitHub. Travis checks. If good, push it to our own repository. All the standard things work. Okay. And this is how you do it. You've got a little bit more code here. Essentially, we don't want to push a package to a repository if it's a branch, for example, or if it's a pull request. So we've got a little if statement. And then deploy.shell is just a shell script with a few git commands. And that's it. If you don't like email, you can try pushbullet. Okay, so pushbullet would be a way of getting text messages or browser notifications or all those sorts of things. Okay, so yeah, that's another nice thing. The thing in line 3, the the sys.get environment, essentially you can have encrypted variables in Travis, right? So you might not want to put your password. When I say might, you don't want to put your password in plain text in Travis. And so you can set it up to encrypt that. And I spent a good hour trying to sort of unencrypt it by hacking it, so doing a pull request, but saying, print that variable out, for example, right? That doesn't work. Same idea applies to Slack and Friends and Twitter. So you can do all these different services. It's all quite easy to put in. All cool kids use Docker, right? So that's the sort of the hip and trendy thing. And again, it took me about 3 minutes to hook it up to Docker. So that's not to do with Travis. It's a separate service. But essentially, if you use Docker Hub, you can link it to your Travis, your GitHub repository, and your Docker container just builds. So that's quite nice. Again, everything's automated. This is essentially the Windows version of Travis. And what we do is not only do we build all the Linux binaries, we also build the Windows for 3.3, 3.4, 3.5. Drat then pushes them all up to a repository. So we now have a repository filled with all these different packages, which we've not touched. It's just everything's automated. And that's quite nice as well. Right? So we're getting lots of stuff. So why would you want to use this? So we do lots of courses. So we're teaching courses almost every week, and there's about half a dozen of us. And the way we do our course is we send participants sort of one command: install the course package. That's it, right? We don't give them install Shiny, install Markdown, install Knitr. We just say install our package for today. And that one package contains all the dependencies. That one package contains all the vignettes, all the practicals, all the solutions. That package contains all the notes. It's one command. Right? And if they can do that, then they can do everything in the module. Right? And because we've checked it under all these operating systems, everything's fine. And even better, we can say, well, actually, after this course, if we found a typo, just run this line, update.packages, in a week's time, and you'll get the newer version, and that's great. We also create a Docker image, and then we host it at jumpingrivers.training. So we've got RStudio in the sky, and so if people don't quite get it on the laptops, we can move them over to the cloud, and it's a perfect copy. Right? So that's good. We also maintain this list of user groups and conferences. Again, that's hosted in GitHub. So we've got a list of our conferences and meetings. So essentially, this was initially it was done by David Smith at Microsoft, and we put all his hard work into a GitHub repo. And essentially, people go in, they make a change to the GitHub repo, adding in a user group, adding in a conference. So here's some upcoming conferences. And what we do here is, well, we just use Travis. Okay. So the pages for that website are hosted on GitHub. Anyone can make a pull request. Anyone can make a suggestion. And we get Travis to make sure, was that suggestion sensible, i.e. it's not broken stuff. And then we push that change out to the website. So we just need to click accept. We then pass all the RMD files, and we create a little CSV list of all the stuff. So we've got the data, and so here's a CSV file downloaded. So that CSV file that's not shown up on the screen would just contain the list of username, user groups, locations, members, that sort of stuff. And it's all automated. Right, that's important. So that's all. So essentially this last slide is trying to show you the big picture of how all this stuff fitted in. So down the left-hand side is the Microsoft route. So that was generating all the Windows binaries for all the different versions of R. On the right-hand side, we've got Travis. And here we had some test suite coverage. We had some static code coverage. We had pushing to a drat repository. We had push bullet. And then the two in the middle was where we built a Docker container that's not anything to do with Travis. It's just a separate system. And then also you can do a GitHub integration and pull in Twitter. This is only scratching the surface, right? So you can sort of integrate Git and Travis and all this sort of stuff with lots of different tools. So if you find yourself, you're pushing and then you're constantly doing the same thing, then you're probably doing it wrong. You want to automate as much as possible, right? Especially if you're working in a team. So I don't trust myself. I sort of don't really trust the people I work with even less. And we all make mistakes. We're all human. And so you want to automate everything as much as possible. So thank you very much. And any questions?
Thank you, Colin. We have time for one short question. So, do you have...
Hi. Thanks for your talk. It was really nice. So I have one quick question, which probably is a little bit easier to answer. So I have this problem that I have in my repository. I have a README file, which is a Markdown, an RMD file, and I have to run it every time I push. And I would like Travis to automate knitting this file. Do you know if it's possible to automate knitting this file and then appending it to my commit or something like that?
So you'd use the same sort of trick that we use for pushing to a repository. So essentially, you'd add in you wouldn't push the .md file. So when you push to Travis, after success, you would knit the RMD file. So you can do that using a one-line command. And then you'd need to push back to your original repository. You would need to do two things. One, you'd need to supply the key, the API key, to do it securely. And two, you need to avoid getting into an infinite loop. So, you push and then you recommit and then you push. And that would just require sort of one or two little bits. Maybe check the commit message, for example. So you could have a particular regular expression of, if it's this commit message, don't do anything after success, for example. But yeah.
Awesome, thanks.
Thank you again.